Okay, folks, I'm so sorry. I neglected two little things. Sometimes the examples in the book are not quite adequate. There's one concept you're going to come across that's not covered in the examples, and I also forgot to give the assignment. You thought you lucked out on that one. Now I'm going to give you the assignment here. I'll tell you, let me give you the assignment first, lest I forget again. The assignment is to be on page 299, cool page number, we're almost into the 300s here. Numbers 2 through 32 even. Numbers 2 through 32 even. But in order to successfully do some of those, you need a little more detail than I gave you earlier, and that is this. How do you do the square root of x to the third? It's very similar to what we've already looked at. In your head, you think of this as being the square root of x squared times x, right? Well, which one of these can paching? Well, we know the square root of x squared. It pachings, becomes an x on the outside, sort of. And on the inside, we're still stuck with this poor lonely x to the first, and we're practically done except for one important detail. Even index, we have to take the absolute value of x. This guy, same story. Square root of x to the fifth. Think of it as, you can think of it as either the x squared times x. Well, what's the square root of x squared? X. What's the square root of x squared? Another x. Altogether, x squared on the outside times the square root of x. Or perhaps a simpler way to think of it is this. Square root of x to the fourth times x. What is the square root of x to the fourth? What would you multiply by itself twice to get x to the fourth? X squared times x squared. Ah, yes. So the square root of x to the fourth is x squared. There is an easier way to think of this, which we'll see in a later section. So the square root of x to the fourth is x squared, because after all, x squared times x squared is x to the fourth. And we're stuck with the x inside. And one more example, and then I'll cut you loose here. This guy, a couple concepts going on. This is a cubed root, be careful. So I asked myself, first of all, are there any cubes that go evenly into 16? Oh, 4. No. 4 is not a cube, 4 is a square. Oh, yeah. So what's the cube root of 16? All right. Doesn't 8 go into 16? Yes. And isn't 8 a perfect cube? Yes. So I know the cube root of 8 is 2. It goes pa-ching. So the 2 pops out. But after I pop out that 2, I'm going to leave some space there. After I pop out that 2, because I took out the 8, pa-ching, I'm still left with that 2 inside. Don't we take the absolute value? Oh, well, there are two reasons we don't, because number one, we already know the absolute value of 2 is 2, but we wouldn't take it anyway because it's an odd index. Do not take absolute value if the index is odd. Now what about the cube root of x squared? Oh, is that just x? No. X times x is not x squared. We don't know the cube root of x squared, so we're stuck with it inside. Sorry. Now what about y to the 8th? That y to the 8th could be written as y to the 6th times y to the 2nd, correct? And what's the cubed root of y to the 6th? Oh, I know. Yes? That would be a y squared. Right. So we pop out the y squared, and we're left with a y squared inside. Because y squared times y squared times y squared is y to the 6th. The y to the 6th pa-chinged out. Cubed root of y to the 6th is pa-ching, y squared. And we're done. And there's one other thought here. What if we have this? How about the square root of x to the 4th? Well, that's going to be the same as the square root of x squared times x squared. So clearly the square root of x to the 4th must be x squared. But it's an even index. So we take the absolute value. But wait just a moment. Do we really have to this time? What does absolute value do? Absolute value makes our answers turn positive, right? Well, tell me something about x squared. Doesn't x squared already have to be positive? Anytime you square a real number, the answer will always be positive. So if x squared is already guaranteed to be positive because we're squaring it, if x squared is already guaranteed to be positive, why do I need to repositize it? There's another peer word I'm going to put pa-ching and repositize in my peer dictionary someday that I'm never going to write. Why do I need to repositize something that I already know is positive? Answer, I don't need to. So I could simply write x squared as my final answer. But if I do have absolute value, is that wrong? No. And have I ever taken credit off on a test for having that? I don't think I ever have. It's not truly simplified. Simplified is x squared. But having the absolute value there does not hurt. When does it hurt? If I've got the cubed root of x cubed and I write absolute value of x, that is just plain wrong. Because what if x happens to be negative 2? If x is negative 2, then the cubed root of negative 2 cubed is going to be negative 2. If I then take the absolute value of that, it's wrong. So you never have absolute value with an odd index. You usually need it with an even index unless you know that what's inside here is already guaranteed to be positive, then you don't need it. Confusing enough? Good. All right, sorry about having to put out a supplemental. Hopefully it's been helpful, especially the fact that I just gave you the assignment, which is page, 299, numbers 2 through 32 even. See you later.